So welcome to lesson number 5, Refraction 2. We're now on the third part of this lesson, 5 part 3, the power of the lens. Now, you've come across that term power in physics before, but it's going to have a different meaning to your normal meaning of power. Power from mechanics would be work divided by time, or the rate of doing work, or the rate of using up energy. Make sure your notes are downloaded. We're now going to go to that section. And here we go. 5 part 3, the power of the lens. So let me explain it in detail using the board. So we're going to call the power of the lens P. But as I've already said to you, it has a different meaning to power in physics being work divided by time. I've got here 2 convex or converging lenses. I've got a thick lens. You can see it's much thicker at the center. And I've got a thin lens, thinner at the center. Now, what is the effect of each of those lenses on light? So, for example, let me say that I send in a ray of light parallel to the principal axis. I will just have it bending once as usual about that central line. Now, because the glass is very thick, it's going to bend by quite an amount. And as a result of that, that ray of light will come down very, very quickly towards the principal axis. Now, the point of the principal axis through which it goes is called the focus, of course. So there's the focus. Now, you can see in that case there, the focus is a very short distance from the lens. The distance of the focus to the lens, that's called the focal length, little f. So little f is a small number. I say that lens is very powerful. Why do I say it's powerful? Because it bends the light by quite a lot. So I would say that lens has a high power. And that high power means that the focal length will be a small number. So high power means a low focal length. That'll give you some idea of what kind of formula I'm going to actually formulate later on. Let me now go to the second lens. It's a much thinner lens. Let me send in a ray of light parallel to the principal axis. Because the lens is very thin, it's not going to bend the light that much. So by the time it comes down to the principal axis, it'll hit the principal axis a long way from the lens. Of course, that point it goes through, that point is called the focus. And you can see in this case that the focal length is much longer. So I say that lens has a low power, a small number. And if it's got a low power, that means f will be a big number. So you can kind of see an inverse relationship between them. If the power is very small, the focal length is very long. The power is very high, like here, very thick glass that bends the light a lot, then the focal length will be very small. So somebody has to think about a formula to capture that information. And this formula makes common sense. The formula is the power of the lens is 1 over f. That makes sense, doesn't it? Because if f is a big number like here, 1 over a big number gives you a small number for the power. But over here, if f is a small number, 1 over a small number will give you a big number for the power. So that makes perfect sense. There is a formula for the power of a lens. It's 1 over its focal length. Now, what do the symbols mean? Well, up to this point, when we did lens problems, mirror problems, we normally left everything in centimeters. But here, I'm actually going to change things to meters. So, F will stand for the focal length of a lens. But I want that focal length to be in meters. And therefore, P, the power, the units for power are going to be 1 over meters, or meters to the power of minus 1. So they are the units for power. Now, that's one formula we're going to use. And then one more formula we're going to use is when you put different lenses together, you add the individual powers to get the overall power. So the power of two lenses together is the power of the first lens plus the power of the second lens. You can simply add the powers together. So they're the two formulae I'm going to be using. If I go back to my notes, well, there they are there. P is equal to 1 over F. And my other formula is the overall power is the sum of the individual powers. There is another formula down here. You don't really need it. It's there if you want. But these are the two most important formulae you need. Now, these formulae are in your table book. So I say make sure you colour in. They're on page 60 in your table book. So make sure you colour them in. There's P is equal to 1 over F. And there's overall power is P1 plus P2, the sum of the individual powers. So with all that in mind, let me now do an example. And the example I want you to go to in your notes is example number 5. So in example number 5, I've got two convex, they're also called converging lenses, of focal lengths 10 centimeters and 25 centimeters are placed in contact. They're asking you to find the overall power and focal length of the combination. So that's example number 5. So let me go to the board to do that question. So two convex lenses, focal length 10 centimeters. That's a short focal length. So therefore, it should be a thick lens. So I'm representing that lens number 1, whose focal length is 10 centimeters. We'll call that F1, focal length 1. And the other one is 25 centimeters. That's a longer focal length, which means it's less powerful. So it's a thinner lens. So we'll call F2 25 centimeters. So we're now going to put those two together. The question I'm being asked is, what is the power and what is the focal length of the combination? Well, let's go through it. Let's write down lens 1. What's its focal length? We call it F1. F1 is 10 centimeters. And what did I say when you do problems from now on using power of a lens? Well, I want you to turn the focus into meters. So divide that number by 100. You do that in your head. Just jump the decimal point at the end, 2 to the left, and you get 0.1 meters. What is the power of that particular lens? Well, my formula for power is power equals 1 over F. In this case, power of lens number 1, P1, is 1 over F1. That's equal to 1 over 0.1 meters. So the power of that lens will be 10 per meter. Now let me go to lens number 2. So lens number 2. What's the focal length of lens number 2? F2 is 25 centimeters. What's the first thing I should do? I should turn that into meters by dividing by 100. And that's 0.25 meters. What's the power? Power is 1 over F. In this case, power 2 is 1 over F2. So it's 1 over 0.25 meters. Put that into your calculator, do it in your head, and I get 4 per meter. So it kind of makes sense, doesn't it? So if the focal length is 10 centimeters, power is 10 per meter. And that's more powerful than lens number 2, which is only 4 per meter. So you can see number 1 is thicker and number 2 is thinner. So now I'm ready to work out the overall power. So let me write down my other formula. My other formula is the overall power is P1 plus P2. So put my individual powers in. P1 is 10 per meter. P2 is 4 per meter. So my overall power is 14 per meter. Because we're talking about convex lenses, the focal lengths were positive. And if the focal lengths are positive, that means the powers are also positive. That is positive plus 14. What kind of lens will the combination look like? Well, it's going to be more powerful than either of the other two. So if I was to do a sketch of it, and I've already done this in your notes, then the combination will be thicker lens than the other two. Now, the last part they're asking me is to work out the overall focal length. Well, you know that P is equal to 1 over F. I now want F, so slide the F up and the P down. That means F is equal to 1 over P. So F is equal to, this is the overall focus of the combination, is 1 over 14 per meter. So I'm going to get my calculator out, and I'm going to put 1/14 into my calculator. And I get, say, 0.071. 0.071. And those units, when they come up, will become meters. Now I suppose we'd better revert. You see the way they gave the focal length earlier in centimeters? Well, let's give the answer back in centimeters. Don't have to. That will give you full marks in the exam. But to turn that back into centimeters, multiply by 100, and I get 7.1 centimeters. It's the focal length of the combination, which is shorter than either of those two, which is correct, making it more powerful. Okay, let's move on to another example. Example number 6. We're now going to combine two different lenses. One a convex or converging lens of focal length 40 centimeters. That will be plus 40 because it's got a real focus and it's placed in contact with a concave or diverging lens of focal length 25 centimeters. That will be minus 25 because it's got a virtual focus. So rays of light never actually pass through it. They only appear to come from it. You know all that from doing your lenses in the previous part of this lesson. Calculate the overall power and focal length of the combination. And they're asking me, does the combination behave overall as a converging or diverging lens? So let's tackle that problem. Let's have a look at it in detail on the board. So, I've got a convex lens, which I've sketched here. Focal length is plus 40 centimeters. So I'll say F1 is 40 centimeters. And it's placed in contact with a concave lens, and that's got a focal length of 25 centimeters. So we call this one here focal length 2. And I'm going to make it minus 25 centimeters when I put it into mathematical equations. It's a virtual focus. So the question is, now I put them together, what kind of lens do you get? What is the overall power of that lens? What's the focus of that lens? And does it behave as a converging or convex lens? Or does it behave as a concave or diverging lens? So that's what you have to answer here. Let's do our mathematical treatment. We've only got two formulae to play around with. So lens number 1, F1 is 40 centimeters. When you do these problems, turn focus, focal length into meters. That's 0.4 meters. P, the power of that lens, is 1 over f. In this case, P1 is 1 over f1. So it's 1 over 0.4 meters. Put that into your calculator, do it in your head, and that gives me 2.5 per meter. That's the power of that first lens. Now let's look at the power of the second lens. Well, f2 is minus 25 centimeters. The minus is crucial. It's crucial because you can imagine when the light comes in to the first lens, it gets pulled down. When it hits the next lens, it gets pushed up. So if you like, it decreases the power of the first lens. That's why the negative comes into play. So f2 is equal to minus 25 centimeters. Turn that into decimal. That's minus 0.25 meters. And what's the power of that lens? Power 2. So power 2 is 1 over f2. That's 1 over minus 0.25 meters. Throw the minus out in front. And 1 over 0.2 is 4. So I get minus 4 per meter. So I've worked out the individual powers of each of these lenses. Now to work out the overall power of the combination, I'm now going to use my formula by adding the powers together. So P is P1 plus P2. P1 is 2.5 and P2 is minus 4. So that will give me minus 1.5 per meter. So the question they're asking at the very end is, does it behave as a converging or diverging lens? Well, the answer will be it behaves as a diverging lens or a concave lens because power is negative. Let me work out the focal length of that combined lens. So P is equal to 1 over f. Therefore, f is equal to 1 over p. So throw the minus in front. That's minus 1 over 1.5 per meter. So 1 over 1.5, 1 over 3.2, I'll end up getting minus 2/3 of a meter. 2/3 of a meter? It's about 66.7 centimeters. So if I'm turning that into centimeters, it's minus 66.7 centimeters. So that's the focal length of the combination of those two lenses. And what I'll end up here, if I was to draw it, would be a concave lens that's really thin, much thinner than the one there in front of you. That's my answer for that. Okay, I think I've done enough questions on it. Now it's over to you, of course, as usual. And I want you to do the exercises. So I think from the exercises at the end of this lesson, we've already done what I think we did. Let's see. Yeah, we already did 1 to 10. So you're doing from 11 onwards. They involve powers. You're going from 11 down to 16.